So here we're going to talk about how to solve a quadratic equation. Now, I just want to point out, remember, a quadratic equation is an equation in which the biggest exponent is a 2. Okay, this is called a second degree equation. So you have an x squared term, okay? And the a, the b, and the c just represent numbers. We've already talked about how to solve a quadratic equation by factoring, right? You take the equation, set it equal to 0, you factor it, and then we just set each factor equal to 0 and solve. Now, today we're going to be talking about another method called the quadratic formula. The quadratic formula is very important because, not everything can be factored, not everything can be solved like we did up here. The quadratic formula, we can use that for any quadratic, whether it can be factored or not, and we can come up with solutions. So this is what we're going to take a look at in this video. In the next video, we're going to take a look at a third technique called completing the square. Okay, so if you turn to the next page in your packet, we're going to be taking a look at a few examples together. Now, this formula right here, okay, this is the quadratic formula. When you're given an equation, right, a quadratic equation, the number in front of the x squared is the a, the number in front of the x is the b, and the number without a variable on it, right? Technically, there's an x to the 0, but this number all by itself is the c. So you're going to look at your equation, and you're just going to plug your numbers into this quadratic equation. Okay, so now let's take a look at number 1. Now, the first thing you want to do before ever using the quadratic formula, see how this up here, the equation is set equal to 0? The first thing you want to do is you want to make sure your equation is set equal to 0. So let's make a note of that. Okay, so that's super important, okay? So make sure you write that out at the top of your page, put stars next to it, make it stand out, okay? You first set the equation equal to 0. Okay, so if we take a look at number 1, this does not say equals 0. So what I'm going to do is I'm going to take this 6x and move it to the left-hand side of the equation. Now, when we do that, technically what we're doing is we're subtracting 6x from both sides of the equation. If you want to write out minus 6x and then minus 6x and show that you're doing that, you definitely can. But at this point in math, you no longer have to show that. We know that if we take a 6x and move it this way, it becomes a negative 6x. Okay, now here's the other thing. We want to make sure that we order our terms in standard form. So we want the term with the biggest exponent first. So the x squared comes first. Then the term with the x, right, the 6x that is becoming negative when we bring it to the left-hand side of the equation. And then we're going to have our number that's all alone. And because we moved everything from the right-hand side of the equation, right, there's nothing left here, we could write equals 0. And that's what we wanted. We wanted our equation set equal to 0. Okay, if you want to make a list off to the side of what a equals, b equals, and c equals, you can, but that's totally up to you. So a is the number in front of the x squared, so in here, this would be a 1. B is the number that's in front of the x, and don't forget the sign with it right here, it's negative 6. And then c is all alone right here. This is our 2. Okay, so we're going to use the quadratic formula, and we are going to plug the numbers into this. Now, see how there's an equal sign, right? This is an equation. It is super important when you write the quadratic formula that you keep that equal sign, that you keep it as an equation. So please make sure you write x equals in front of it. That's what we're doing. We're solving for x. Okay, so I'm going to write out x equals. Okay, so it starts off here with negative b. Now let's think about it. Negative 6 would be positive 6. So I'm just going to jump into writing positive 6. If you want to write negative 6, you can, but I like to just write positive 6. Okay, so now we see we have plus and minus, so I'm going to write plus and minus. And then I'm going to put a big radical, okay, a big square root. So it says b squared. So my b is negative 6. Now remember, when you square a negative, if you just write this, we're going to wind up getting the wrong answer, right? We want to square the whole thing. Whenever you square a negative, we need to put it in parentheses. Without the parentheses, it's actually incorrect. Okay, then it says minus 4 times a, which is 1, times c, which is 2. So I'm going to plug that in. So minus 4 times a, which is 1, times c, which is 2. And then that whole entire thing, okay, make sure you extend the fraction bar even over here, right? It doesn't just start here. The fraction bar, the negative b has to be on top of it. It's going to be over 2a, so 2 times 1. So I'm going to bring down my x equals, right? I want to keep it in equation the whole time. 6 plus and minus. Now, we're going to keep this as a radical. So basically what we need to do is we need to figure out what this is equal to under the radical. So negative 6 squared would be positive 36. And then 36 minus, well, 4 times 1 times 2 is 8, right? So 36 minus 8 would be 28. And I'm keeping it under the radical. I'm not doing anything with the radical yet. So even if you are doing this in your calculator instead of in your head, do not actually plug the radical in your calculator. You're just plugging in what's underneath the radical. Okay, and then I'm going to put that whole thing over 2 times 1, which is 2. Okay, now here's the deal. If you look at this, right, radical 28, that is not a perfect square. If it said radical 25, we could just cross it off and say, all right, radical 25 is equal to 5, right? But 28 is not a perfect square. So what we want to do, I like to do it off to the side, is we want to break this up into 2 separate radicals. The first radical is our perfect square radical, and the second is like the leftover, whatever is not a perfect square. Now you want to find the biggest perfect square that divides evenly into 28. I mean, actually, the only perfect squares that divide evenly into 28 are 1 and 4. So 4 is the biggest perfect square that divides evenly into 28. So what I'm going to do is I'm going to break this up into a radical 4. And then since 28 divided by 4 is 7, I get a 7. Now we know that the square root of 4 is 2. So that's going to give us 2 radical 7. Sorry, that doesn't really look like a great 2. So now what I'm going to do is I'm going to come back over here, and when I rewrite this, instead of having a radical 28, I'm going to rewrite it as 2 radical 7. All right, so we have x equals 6 plus and minus 2 radical 7 over 2. All right, we're almost done. Now we're just going to look at all of our numbers that are not under a radical, right? All of these whole numbers and say, well, is there something that divides evenly into all of them? Well, the biggest number that divides evenly into all of them is 2. So 6 divided by 2 would be 3. 2 divided by 2 is 1. And again, 2 divided by 2 is 1. So when I go to rewrite my final answer, I'm just going to bring it to the side here. We have 3 plus and minus 1 radical 7 over 1, which anything over 1, you don't need that on the bottom. And we also don't need this 1 in front of the radical 7. So if you want to leave it as 3 plus and minus radical 7, you can. Now, one thing I want to point out, this is actually 2 answers. Okay, you can leave your answer like this. You could circle it like this. But what this means is, I'll write it off to the side. What this means is, one of our answers is 3 plus radical 7, and our other answer is 3 minus radical 7. So these are both solutions of x. But again, you can just leave your answer like this. Okay, I was just breaking it up just to show you what the plus and minus meant. Okay, so on the next page, we're actually going to take a look at number 6 and number 8. So let's start with 6. Now, again, first thing we want to do is set our equation equal to 0. So I'm going to take this 9x and subtract it over. If you want to show you're doing that, you can, but you definitely don't have to. Okay, now when you do, I'm going to bring down the 3x squared, and I want to keep it in standard form. This 9x that I'm bringing over, it's going to become a negative 9x, and I want to write that second. Because remember, you want the exponent on the x's to go in descending order. And then I'm going to bring down my plus 6, and equals, since we moved everything over, it is equal to 0. Okay, so again, make sure it's in standard form. X squared, then x, then our number. Okay, that way we can clearly see what our a is, our b is, and our c is. Okay, so at this point, if you want to jump right into the quadratic formula, you definitely can. But what some of you may notice is, look at this. All of these terms are divisible by 3. So, I mean, you could factor out a 3, but personally, if it's an equation, right, you can just, as long as you do to one side what you do to the other, we can divide both sides of the equation by 3. Remember, you're not allowed to divide by a variable because it changes, the degree of the equation, but you can divide by a number, no problem. So that's going to leave me with x squared minus 3x plus 2, and then 0 divided by 3 is 0. So what I did was I made an equation with smaller numbers, which is going to be easier for me to, work with. Okay, so off to the side here, I just wrote out my a is 1, my b is negative 3, and my c is 2. okay? And I'm just going to plug them right into the quadratic formula. So remember, you have to write x equals, right? Keep it in equation. So negative b, so negative 3 is going to be positive 3 plus and minus the square root. Now again, remember, when you plug a negative into, if you want to square a negative, you have to put it in parentheses, okay? So this is no good. Okay, you need those parentheses. And then minus 4 times a, which we said is 1, times c, which we said is 2. Make that a little bigger. Okay, and that whole thing's going to be over 2 times a, so 2 times 1. All right, so we have x equals 3 plus and minus the square root of, all right, so negative 3 squared is 9, and 4 times 1 times 2 is 8, so 9 minus 8 is 1. And that whole thing is going to go over 2 times 1, which is 2. All right, now if you look here, this is a perfect square, right? What's the square root of 1? It's just 1. So I'm going to rewrite this. If it's a perfect square, then it means we're not going to have any radicals left in our answer. We're going to have rational answers, okay? Not irrational with, radicals that have to stay there. So this is going to leave me with 3 plus and minus 1 over 2. Now, when you look at all three of these numbers, there's nothing that, divides evenly other than 1 into all of them. So it's not going to simplify, but this is super important. If you are left with no radicals, you have to take this a step further. It actually is an extra step. You have to figure out what 3 plus 1 divided by 2 is, and then what 3 minus 1 divided by 2 is, and you'll have 2 separate answers. Okay, so let's start here. 3 plus 1 is 4, and 4 divided by 2 is 2. Okay, so 4 divided by 2 is 2. So that's one of our answers. And then over here, 3 minus 1 is 2, and 2 divided by 2 is 1. All right, so this time we wound up with nice, clean, rational answers. And that's what happens when the number under a radical is a perfect square. Also, what that means is we could have solved this. If we went back, we could have solved it by factoring. We could have came up with two numbers that add to negative 3 and multiply to negative 2 and factor t-chart solve. All right, so on to number 8. Now, with number 8, again, we have to get our equation set equal to 0. So I'm going to take the 12x and move it over, and the 117 and move it over. Okay, so this 12x squared is going to come down. When I take my 12x and move it to the left-hand side of the equation, it becomes a negative. And same thing with the 117. When I move it to the left, it becomes a negative. And it leaves me with equals 0 because there's nothing left on the right-hand side. We took these two terms and moved them over. Now, I'm looking at these three numbers. 117, these are going to create really big numbers within our formula. I wonder if there's something that does divide evenly into all of these. All right, well, I know, 2, 3, 4, and 6 divide evenly into 12. So let me see if they divide evenly into 117. Well, it just so happens that 3 divides evenly into 117. So to make my life easier, I'm going to divide both sides of the equation by 3. It's worth the time it takes to just try it out because, it's going to make your life so much easier when you're dealing with smaller numbers within the quadratic formula. Okay, and remember, again, 0 divided by 3 is 0, so this side is still set equal to 0. Okay, now off to the side, you do not have to write this if you don't want to. You could write out your A. Look at this, our B again is negative. That's not always the case, but in the examples I chose here, it seems like they're all negative, right? All right, so let's plug it into our quadratic formula. So we write x equals negative 4, so positive 4, plus and minus the square root. Okay, remember when we plug in that b, it has to go in parentheses if it's negative. You could always just put it in parentheses, whether it's negative or positive. That way you don't really have to think about it. And then minus 4 times a, which is 4, times c, which is negative 39. Over 2 times a, so 2 times 4. All right, so let's keep going. X equals 4 plus and minus the square root of. Okay, now, if you figure out what negative 4 squared minus 4 times 4 times 39 is equal to? It's equal to actually 640. Okay, 640. It's a big number. Imagine how big it would have been if we didn't divide by 3 in the beginning. Okay, then we're going to put that whole thing over 2 times 4, which is 8. Now, one thing I want to remind you guys, you are not allowed to simplify these and make this 1 over 2, right? You cannot simplify these two numbers until you're done simplifying the radical. Because technically, isn't there a 1 in front of that radical? And you'd have to be able to divide this number in front of the radical by the same thing you're dividing these two. Okay, and we can't. So when you're using the quadratic formula, all 3 numbers, even though we can't see it, there's a 1 there, all 3 numbers on the outside have to divide by the same number. Okay, so at this point we can't simplify. But what we can do is we can take this radical 640. I'm going to just do it off to the side. And, you know, if it's a number that big, I would plug in my calculator the square root of 640 and see if it's a perfect square. Because if it is, it's going to make your life easier. You just write it as a whole number in the next step. But unfortunately, although 64 is a perfect square, right, 640 isn't. So we're going to have to break this up into 2 separate radicals. Okay, now what you're going to want to do is you're going to want to find the biggest perfect square that divides evenly into 640. I mean, what you could do you remember this calculator trick? You could type in 640 divided by x, and then you can go to your table of values, right? And you can scroll up and down until you find the biggest perfect square that divides evenly. Like as you scroll down, right? 4 is a perfect square, and that does divide evenly into 640, but let's see if there's a bigger perfect square. Let's keep going. Okay. 9, no. If we look at, see this 10 right here next to it is a 64. I wonder if we can find a bigger perfect square that divides evenly into it. Well, if you think about it, as we go down this list, the y values are getting smaller and smaller, right? Aren't these getting smaller? So the bigger y values would be as we scroll up. And as we scroll up, look at this, look at the y's. Notice if you see any perfect square bigger than a 64. No, no. No, so there you go. It's going to be, I'll scroll back down, 10 and 64. Okay, so right here they are. And, you know, sometimes it's going to take a little bit of trial and error. I mean, if you have a big number like that, it could be, you know, a little time consuming to find them. Okay, so let me get rid of these. So I'm going to break this up. Remember, my perfect square goes in the first radical, and the leftovers go here. Now, some of you may be looking at the 10 and say, does that break up further? Well, the only thing that multiplies to 10 is 1 and 10. And 5 and 2, and neither one of them is a perfect square, so that does not. So we know the square root of 64 is 8, and then you bring down the leftover radical, so 8 radical 10. All right, so let's come back over here. So x equals 4 plus and minus, and we're going to replace this radical 640 with what it's equal to in, this is called simplest radical form. Okay, we simplify the radical as much as possible. And then that's going to be over 8. So now, once we finish simplifying the radical, now we could look at all 3 numbers. Remember, you can't just do 2 out of the 3 numbers. You have to do all 3 of these, right? So with the quadratic formula, simplifying all 3. The biggest number that divides into all 3 of them is a 4. Okay, so this 4 is going to become a 1, and both of these 8s are going to become 2s. So it looks like we're going to be left with 1 plus and minus 2 radical 10 over 2. Okay, and that's 2 answers, right? Technically, we know this means 1 plus 2 radical 10 over 2, and then 1 minus 2 radical 10 over 2. So those are our 2 answers.